So we are going through tutorial sheet for mathematics. It's on quadratic functions. Question 1 is saying given that the equation p of x is equal to negative 2x squared plus 180x minus 1000, where x represents the number of items sold, it describes the profit function for a certain business. How many items should be sold to maximize the profit? Now, this question is basically testing you up. Are you able to complete the squares and are able to sketch a quadratic function? So p of x is equal to negative 2 x squared plus 180x minus 1000. When you want to complete the squares, the first thing that you want to do is to make sure that the number in front of x squared is a 1. So I'm going to get these two terms here and factorize out negative 2. Please only get the one with x squared and the one with x. If I factorize negative 2, I'm going to remain with a positive x squared. From 180, if I remove negative 2, I'm going to remain with negative 90x and then minus 1000. Okay, like that. So now that the number in front of x squared is a 1, we can now complete the squares. And how you do that is simply, so you are going to write negative 2. I'm going to put it in a big bracket like this. And then I'm going to be dealing, I'll put another bracket. So I write x without a square. And then I'll put the sign, the same sign here minus. So I'll take the half of 90. Now the half of 90 is a 45. So I'll write 45. I'll close. Okay. And then what I'll do is that now I'm going to square, I'll put a square here. Have you followed what I've done? I just wrote x the same without a squared, I put it there. Minus I got 90 divided by 2, it gave me 45, I put it there. And then I put a square, don't include x. And then here always put a minus. Whether there is a plus here or there is a minus, always put a minus after the bracket. And then what you do is this same number that you found here, the 45 squared. So what is 45 squared? Now you know 45 squared is the same as 45 times 45. That is going to be a 2025. And then now close. What I've written inside these big brackets is the same as x squared minus 90x. Okay, it's the same. And then I write minus 1000 at the end. At this point now I'll get this negative 2 and multiply with everything inside the big brackets. So that is going to be negative 2 times x minus 45 with a square. Please don't make a mistake of getting this negative 2 and multiplying with the x alone and with the 45 alone. Why? Because these two terms have got a power 2. Okay, there's a question. So the 2025 is I got 45 and squared it. Does that make sense? Mm. So you always get this number here, you always get this number and square it. Pardon? So that number is not, so the 1000 is still unaffected. The 1000 is still here. The aim is if I get x minus 45 squared minus 225, I expand it, it should give me back this thing here. Okay. So after doing this now, remember I'm distributing this negative 2. Okay, we can close the mic now. We'll distribute this negative 2. So I got negative 2 and multiplied with x minus 45 squared, and then I'll get negative 2 and multiply by 2025. and that is going to give me, because I'm multiplying a negative 2 and negative 2 and 2025, it will give me positive 4050, and then I've got a negative 1000 at the end. And so this is going to give us negative 2x minus 45, 4050 minus 1000, that is going to be 3050. So having done this, you can now sketch your graph. We can now sketch our graph, and I'm going to put it like this. So I hope sketching quadratic graphs is really easy. So don't worry anything. Okay, it's really easy. There is our x, there is our y. The only thing that you look at is the turning point. And as you sketch a quadratic, what you should understand is this. Okay, sorry. What you should understand is that as you sketch these functions, the turning point is always, you get this number in front in the brackets x minus 45, you get it to 0. In other words, just get the 45, change its sign. It's positive 45. The number that is outside, 3050, that is going to be the y coordinate. So therefore the turning point is at 45. Let's say 45 is here, comma 3050. Let's say 3050 is there. So we can now predict the graph. So this is the turning point. And just look at the function itself. If the number in front of the function is negative, it means that the function is big, it will be going downwards. Okay, it will be going downwards. So this function will be going like that. If the number in front of the function was positive, it means that the function would have been going upwards. Important values that you have to find when you are sketching the graph is, can you see this number here? This is known as this happens when x is equal to 0. That's the y-intercept. So the meaning of that is that this graph will actually not move the way I've drawn it. It's as easy as that. So let me put I'm going to put 45 at another point. I'm going to put 45 here. So this is going to be the turning point. When x is 0, put 0 here, put 0 here. What will be the value for y? Y will be negative 1000. So negative 1000 is somewhere here. This other value is not looking clear. This is a 3050. So this graph is actually going to come and it is going like this. Supposed to come and pass at negative 1000. That's a y intercept, and then supposed to turn this direction and go like that. So the other important values, if it were an exam, that you have to find was this one here and this one here, which are the x-intercepts, and those happens when y is equal to 0, so supposed to solve for those. But the only thing that we're interested in this question, I could have answered this question without making a graph. I'm just doing this so that you can just see what has to happen. Okay, so we've been told that x represents the number of items sold, where x represents, and then profit of the function for a certain. So given that the equation, this, where x represents the number of items sold, And then if px, that's a profit, or y is a profit. How many items would be sold to maximize the profit? So maximum profit is here. The maximum profit was 3050. That's the maximum profit. So how many items have been sold? You can see it's 45. 45 items have been sold for you to attain maximum profit. That is how you find that one. Does it make sense? So it's basically you applying the principle of maximum and minimums. I hope it makes sense, all right? The next question is saying, given that the roots of the equation of the quadratic equation x squared minus 4x minus 2 is equal to 0 are alpha and beta, find the value of the following. Now, before you find anything for roots of a quadratic, you always need to find alpha plus beta and alpha times beta. Alpha plus beta is given by negative b over a. So negative b is, you can see x squared minus 4x. B is the number in front of x. That's a negative 4. A is the number in front of x squared, which is a 1. So alpha plus beta is going to be 4. And then alpha times beta is equal to c over a. And c in this case is the constant, which is negative 2. A is still 1. So therefore, this is going to give us negative 2. So having found this, now we can work out all other questions. Want to find for a alpha over beta plus beta over alpha. So what I'm going to do is this. I'm going to move this down. Okay. So we can answer A. We are trying to find alpha over beta plus beta over alpha. Now the way you answer this is that you need to make sure that your function, the term that you are dealing with, should be added up. Okay, should be the same function. Okay, so this therefore is going to be, make it as a single fraction. Get the alpha on top of the first fraction, multiply with the alpha down the second. That will be alpha squared. Multiply the beta down and the beta on top. That will be beta squared. And then multiply the two denominators. That's alpha beta. This is how you add fractions. Now we don't have alpha squared plus beta squared. We don't know what that means, because the only thing that we have that we can substitute is alpha plus beta and alpha times beta. So where there's alpha squared plus beta squared, you need to know that alpha squared plus beta squared is the same as alpha plus beta squared minus 2 alpha beta. This is if you know how to expand or to factorize. To say, if you factorize alpha squared plus beta squared, you get alpha plus beta squared minus 2 alpha beta. And then in the denominator, we're going to have alpha beta. In case you don't know how it comes about from alpha squared plus beta squared to alpha plus beta squared minus 2 alpha beta, there are two things you can do. Either just swatter that's how it's supposed to be, or you can watch my video on rules of a quadratic equation. Just type on YouTube, Cedis Academy rules of a quadratic, it will come. So alpha plus beta, remember alpha plus beta is a 4. So I'm going to put a 4 there. But this is alpha plus beta squared. And then minus 2 alpha beta, remember alpha beta is a negative 2. And then again in the denominator, alpha beta is a negative 2. So this is going to give us 4 squared is 16. Negative 2 times negative 2 is positive 4 over negative 2. 16 plus 4 is a 20. 20 over negative 2 is a negative 10. So that is the answer for this one. Is there anyone that is left behind? Anyone left behind? Okay, good. The next question we're supposed to find is b, alpha to the power 3 plus beta to the power 3. It's also very easy. Alpha to the power 3 plus beta to the power 3. The only thing that you need to know is if you factorize alpha to the power 3 plus beta to the power 3, what do you get? So you get alpha plus beta, okay, and then alpha squared minus alpha beta plus beta squared. This is the expansion. Again, you either know swatter it or you go to my video to see how it comes about on roots of a quadratic. Again, this will be alpha plus beta. I'm going to put the alpha plus beta in brackets together. The alpha squared, I'll put it together with the beta squared, and then I'll write minus the alpha beta alone. Okay, like that. Further, this will be alpha plus beta. Remember what alpha squared plus beta squared means? It means alpha plus beta squared minus 2 alpha beta. Now, there's supposed to be a 2 here. Actually, let me do this. So in case you get confused like the way I want to be confused like now, you can just try to do a simple test. Okay, like a simple test. Just multiply. If you multiply this, it's going to give you alpha squared beta. If you multiply this, the second one with this, it's going to give you alpha beta squared, like that. And then if you multiply the next, this with this, it's going to give you alpha cubed. This times that, it will give you alpha beta squared. So there's no need to put a 2 there. Like if you try to expand, it will give you the same thing. It will give you alpha to the power 3 plus beta to the power 3. So that's the goodness with mathematics. So I was saying, where there's alpha squared plus beta squared, we're going to replace alpha plus beta squared minus 2 alpha beta. But remember, we've got another minus alpha beta. So this is going to give us now alpha plus beta, and then we are going to have alpha plus beta in brackets squared, negative 2 alpha beta minus alpha beta, that will give us negative 3 alpha beta. Okay, sorry. Let me just move the board again a bit down. Okay, so there. So we are saying that we come back here and we are putting alpha plus beta squared minus 2 alpha beta minus alpha beta, that is 3 alpha beta. Where there's alpha plus beta, remember that's supposed to be a 4, and then open. Where there's alpha plus beta again, there's going to be a 4. That's 4 squared minus a 3. Where there's alpha beta, it's a negative 2. And so this is going to be 4. 4 squared is 16. So I've got 16 plus a 6. 16 plus a 6, that is a 22. So 22 times 4, that's 88. I hope that is clear with everyone. So that is how you answer that part of the question. The next one, let's answer C, alpha minus beta squared. So alpha minus beta squared is the same as expand alpha minus beta squared. The way you expand this, because you can't deal with something that has got a minus. Remember, we only know alpha plus beta and alpha times beta. When you expand something raised to the power 2, is just you get a first term, you square it, you get a power 2, multiply with everything inside. So 2 times alpha times negative beta, that will be negative 2 alpha beta. And then get the negative beta also squared, that will be positive beta squared. Put the alpha squared and the beta squared together, so that will be alpha squared plus beta squared and then minus 2 alpha beta. Again, where there's alpha squared plus beta squared, substitute alpha plus beta squared minus 2 alpha beta. But remember, there is another minus 2 alpha beta. So this gives us alpha plus beta squared minus 4 alpha beta. So where there is alpha plus beta, we are going to substitute 4, that's squared, minus 4. Where there is alpha times beta, we're substituting negative 2. So this is a 16 plus 8. And that gives us a 24. Simple, right? That's how it goes. The next one, A, B, C, D. D is saying 1 over alpha squared plus 1 plus 1 over plus beta squared plus 1. So D, 1 over alpha squared plus 1 plus 1 over. There's a question? Okay, the way we also work out this is make sure that you add the fractions. Multiply the one on top of the first with the beta squared plus 1 over the second. That will give us beta squared plus 1. Multiply the 1 on top of the second with the alpha squared plus 1 down the first. That is going to give us alpha squared plus 1. And then multiply the two denominators. Okay, so alpha squared times beta squared, that will be alpha squared beta squared. Alpha squared times 1, that is going to be alpha squared. 1 times beta squared, that is going to be beta squared. 1 times 1, that is a 1. So on top, arrange the terms, the like terms together. You are going to have alpha squared plus beta squared. 1 plus 1 is a 2. Down also, I'm going to start with alpha squared plus beta squared, and then we have got plus the alpha squared beta squared. I can also write them as alpha beta and then squared outside, and then plus a 1. I can come here where there's alpha squared plus beta squared. I'll put alpha plus beta squared minus 2 alpha beta. Okay, and then I'll write plus a 2 at the end. In the denominator also, where there's alpha squared plus beta squared, I'm gonna put alpha plus beta squared minus 2 alpha beta. Okay, and then remember we have got plus alpha beta squared plus 1. And then now we can make substitutions. Where there's alpha plus beta, I'll put 4 squared minus 2. Where there's alpha times beta, I'll put negative 2 and then plus 2. In the denominator, where there's alpha plus beta, I'll also put a 4 squared minus 2. Where there's alpha times beta, I'll put a negative 2 and then plus, where there's alpha beta, I'll put negative 2, but that's squared and then plus 1. So this gives us 4 squared is 16. Negative 2 times negative 2 is positive 4 plus 2. In the denominator, 4 squared is 16. That will be plus 4. Negative 2 squared is another 4 plus 1. So we have got 22 on top. Down we have got 25. So that is how that one goes. Is there anyone that is left out? Okay. So that is how that one goes. Is there another one here? So E is saying 1 over 2 alpha plus beta and then 1 over alpha plus 2 beta. Yes? So the third question, which part? Which part? Here. Okay, so we've just added 16 plus 4. That's a 20 plus 2. That's a 22. And then down 16 plus 4. That's a 20 plus 4. 24 plus 1, 25. Have you seen how it has come about? So it's the same way we are going to work out this one. Just multiply the one down with the alpha plus 2 beta. That's going to be 1 or plus 2 beta. Multiply the one on top of the second with the 2 alpha plus beta down. That is going to be 2 alpha plus beta. And then multiply the two denominators. 2 alpha times alpha is 2 alpha squared. And then 2 alpha times 2 beta, that is going to be 4 alpha beta. Then beta times alpha, that is alpha beta. And then beta times 2 beta, that is going to be 2 beta squared. So at this point, just simplify things. On top we have got alpha plus 2 alpha, that is going to be 3 alpha. 2 beta plus beta, that is going to be 3 beta. In the denominator, we have got 2 alpha plus 2 beta. I can put those together. And what I can, so 2 alpha plus 2 beta. 4 alpha beta plus alpha beta, that is going to be 5 alpha beta. And then on top, I'm going to factorize out a 3. We remain with alpha plus beta. There are these parts that have got a squared. I think I forgot a squared. This is supposed to be squared. This is supposed to be squared. So in the denominator, I'm going to factorize out a 2. So we remain with alpha squared plus beta squared, and then plus 5 alpha beta, and that is going to be equal to 3 alpha plus beta over 2. Where there's alpha squared plus beta squared, I'm going to put alpha plus beta squared minus 2 alpha beta, like that. And then we have got plus 5 alpha beta. And this is going to be equal to 3 alpha plus beta divided by, or multiply 2 times alpha plus beta square, that is going to be 2 alpha plus beta squared, 2 times negative 2 alpha beta, negative 4 alpha beta, and then we have got a positive 5 alpha beta, and this will give us 3 alpha plus beta over 2 alpha plus beta squared, negative 4 alpha beta plus 5 alpha beta, that will just give us alpha beta. And now we substitute, this will be 3 alpha beta, we know that's a 4. In the denominator we have got also 2 alpha beta plus beta, that is 4 but is squared, and then plus alpha beta, that's a negative 2. This is going to be equal to 4 times 3, that is a 12. In the denominator, 4 squared is 16. 16 times 2, 32 minus 2, which is a 12 over 30. Now 12 over 36 into 12 is a 2. 6 into 30 is a 5. So that is it. The last part of this question is 1 over alpha plus 1 over beta plus 1. So 1 over alpha plus 1 plus 1 over beta plus 1. Again, 1 on top multiply with the beta plus 1 down. That is going to be beta plus 1. 1 on top of the second multiply with the alpha plus 1. That is going to be alpha plus 1. Multiply the two denominators. Alpha times beta, that is alpha beta. Alpha times 1 is alpha. 1 times beta, that is beta. 1 times 1, that is a 1. I'm going to pair the alpha and the beta together on top, and then I'll add the 1 and the 1. That is going to be a 2. Down, I've got alpha beta. So I'm going to first write alpha plus beta, okay? These two here. I can even put them in brackets. And then I've got alpha beta, and then I've got a 1. And then I'll make substitutions. Where there's alpha plus beta on top, I'll put a 4, but remember there's a plus 2 there. In the denominator where there's alpha plus beta, I'll also put a 4. Where there's alpha beta, I'll put a negative 2, and then plus 1. So this is going to be 6 over 4 minus 2 is a 2 plus 1 is a 3, which gives us a 2. So that is the answer. Does this make sense, guys? Do we get the sense? Excellent. So we are done with question 2. Question number 3. You, s- you see, quadratics are really easy. Yes, please. Okay. So next, okay. So next is find the quadratic equation with the integer coefficients which has roots 1 over 3 and 1 over 4. Now, something that has got these roots. So for A, oh, sorry. Let me just remove this. Okay. So we are saying for A, when you've been given roots, the first thing you need to do is find the sum of the roots, okay, and find the product of the roots. So sum of the roots, add the roots 1 over 3 plus 1 over 4. This is going to give you, I don't know how good you are with adding fractions, but this is 7 over 12. Also find the product of the roots. The product again 1 over 3 times 1 over 4. This is 1 over 12. So the way you find the equation is given by x squared minus the sum of the roots multiplied by x plus the product of the roots is equal to 0. So this will be x squared minus the sum of the roots. Sum is 7 out of 12. So just attach x here. Product is 1 out of 12. This is equal to 0. If I want to multiply this equation throughout by 12, so it becomes 12x squared minus 7x plus 1 is equal to 0. If I leave it on the other step on top, I'll still get all the marks. Okay, so for B, the roots we have is 1 minus 4i and 1 plus 4i. So again, the sum of the roots is going to be 1 minus 4i plus 1 plus 4i, which is going to be, just add like terms, 1 plus 1, that's a 2. Negative 4i plus 4i, that's a 0. They'll cancel. And then the product of the roots, multiply the two guys, 1 minus 4i multiplied by 1 plus 4i. So that is going to be 1 times 1 is 1, 1 times 4i is 4i, negative 4i times 1 is negative 4i, negative 4i times 4i, that is negative 16i squared. Remember, I squared is negative 1, so negative 16i squared is just positive 16. So this is going to be 1 plus 16. Yes, please, there's a question. Hmm. The one you what? In red. Where are you behind? So I just multiplied this throughout by a 12. If I multiply 7 over 12 by 12, the 12 in the denominator goes. Okay, great. So even here again, we are doing the same. X squared minus sum x, and then plus product is equal to 0. So this will be x squared minus the sum. The sum here is a 2. Just put x. Plus the product is a 17. That is going to be equal to 0. That is how you answer that one. And then for C, let's look at the roots that we have. We have got 4. It's not just clear. This is supposed to be 4 square root of root 3 and then 4 minus 2 square root of root 3. So the sum is going to be equal to, we have got 4 plus 2 root 3, add 4 minus 2 root 3. The way you add sides is just like add like terms. 4 plus 4 is 8. 2 root 3 minus 2 root 3, they will cancel. Then go to the product. Again, it is 4 plus 2 root 3. You are multiplying with 4 minus 2 root 3. So 4 times 4 is 16. But you know, when you're multiplying a number by its conjugate, just get a first number, you square it. And then get a second number, you square it. It's as simple as that. I hope you know how to multiply a number by its conjugate by now. So me multiplying everything is just wasting some time. But in the exam, we don't have that time to play, right? We have got many questions to answer. So this is child's play. So all you do is, you can see these are the same numbers, just that one is negative, one is positive on the mid. So just get 4, you square it, and then put a minus here. Get the second part, which is 2 root 3. Also square it. So this is going to be 16 minus 4. 2 squared is 4. Root 3 squared is just 3. So this is 16 minus 12, which is a 4. Therefore, the equation is going to be x squared minus sum x plus product is equal to 0, which is x squared minus the sum is 8, put x there, the product is 4, and that is going to be equal to 0. The last one we have got, this is supposed to be what? Okay, I've seen. So even for the previous one that I'm from doing, the question was, the rules were supposed to be 4 plus 2 square root of 3 over 2. But I've just used a 2. Please, you need to use the 3 over 2, right? That's how it's supposed to be. So for this sake, because I've used the, so I'll just remove that. I've remade the equation. So you can put your, yes. Mhm. Yeah, it's true. You can also do that, but they just want to see if you can, if you know the method. That's also true. But I don't recommend. It's very long and it's gonna take time, alright? But it's correct. You'll still find the correct answer. That's okay? Good. So let's find the sum. The sum for this one is going to be, we have got a 3 plus I. We are adding with 3 minus I. And that is going to be 3 plus 3 is a 6. I minus I is 0. And then the product is going to be 3 plus I multiplied by 3 minus I. 3 times 3 is 9. 3 times negative I is negative 3I. I times 3 is positive 3I. I times negative I is negative I squared. Negative I squared is a positive 1. So positive 1 plus 9 is a 10. Therefore, the equation is going to be x squared minus sum multiplied by x plus product is equal to 0. So this gives us x squared minus the sum is 6x plus the product is 10. That is equal to 0. So this is equation 3. That's how you go about it. So for the questions from question number 4, we'll discuss this in the next class. Okay. But since we've done question 3, you can do this. Find a quad equation with integer coefficients, these. So you are able to answer that. So these other ones we are going to answer. Yeah. Mhm.